Let's now go back to other learning objectives. This course will teach you how to implement solutions to problems using Java in an integrated development environment, or IDE. Java is one of the most popular programming languages in use nowadays. We will be learning a lot more about Java in the coming weeks. The integrated development environment that we are going to use in this course will be mainly Bourgeois, but I'll also introduce another IDE called Eclipse towards the end of this course. There are many programming languages available. Java is just one of them. At the end of this course, although you will have just learned one programming language, hopefully, you will be able to pick up other programming languages by yourself after learning the programming concepts from this course. In fact, using myself as an example, when I learned my first programming language some 30 years ago, well, I just revealed how old I am. Java didn't even exist. I used a programming language called Fortran. But many of the programming concepts that I learned are still applicable today. However, Java is a much better designed language than Fortran. Java is an object-oriented language. This course will give you an understanding of the basic of data abstraction using the object-oriented framework. I want to talk a little bit more about what is data abstraction. Data abstraction separates what are the essential properties of data objects from the details of how they are implemented. That is, the implementation detail of data objects are hidden from the users. In most applications, we usually care only about what the data object can be used for, but not how they are represented. For example, a number can be represented in many ways. In human language, the most commonly used number system is Arabic numerals. They are listed as 1, 2, 3, and so on until 9, and I'm sure that you can recognize all of them, but there are also Roman numerals. Notice that only 3 symbols, a vertical bar, a V, and a cross are used for representing the numbers from 1 to 10, and there's no special Roman numeral for 0. There are also Chinese numerals and many others. And in computers, numbers are represented as zeros and ones. One important observation is that, irrespective of how numbers are represented, we expect operations performed on numbers will obey certain rules. For example, when we add 1 to 2, 3 is expected as the answer, irrespective of whether it is done by a Chinese, a Roman, an American, or a computer. One can come up with other daily life examples using abstraction. In driving a car, when we step on the gas pedal, the car is supposed to accelerate, and when we step on the brake, it is supposed to slow down. But we don't really care the mechanics behind how they work. When you use apps on smartphones, say an iPhone, you need to know only what the apps are supposed to do, but you don't really know how they are actually implemented. You'll find that data abstraction is a very important concept in programming, especially in object-oriented language such as Java. By using this approach, even if the implementation is changed at some later time, the behavior of the data object or program is expected to remain the same. I want also to put this course in the context of computer science. Computer science is a discipline that studies the theory, design, and application of computational systems. This course is designed for both computer science as well as non-computer science majors. For those who have not decided whether computer science is the right discipline for you, this course will give you a taste of what computer science is like. Some of you may decide after taking this course that computer science is not right for you, which is perfectly fine. When we study computational system, there are three important aspects, namely hardware, software, and application aspects. The study of hardware examines the design and construction of computer systems in the form of physical devices for executing programs. The study of software examines the behavior of algorithms or computer programs to determine whether they are correct and efficient. The focus of this course is on the software aspects of computer systems. After all, the main use of computers is for solving real-life problems. In this course, you will learn some fundamental programming concepts for solving problems using computer programs. I'll use a lot of examples that deal with pictures and images to illustrate some of the important programming concepts. There's the saying that a picture is worth 1,000 words. Hopefully, these examples will give you a better grasp of these concepts. You can apply these concepts for solving real-life problems, so hopefully you will learn also to be a better problem solver. I'll elaborate more on these three aspects of computer science in the rest of this lecture.